Okay, now that we've actually watched the two videos discussing the concepts of chi-square and correlation, because it's 2015, we don't actually have to do those calculations by hand. We can have SPSS do it for us, which is great. And so the first thing we want to do is we want to open our data set. And this is all obviously under the Citrix Receiver Boston College desktop window. And I have already saved those data sets onto my desktop, so I'm just going to access them from there. And so for the purpose of this tutorial, I'm going to actually work with the data set that you used for your homework assignments. And so since it's on my data set, or since it's on my desktop, I just have to double click it, and that'll open the data set for me. And so the first thing you want to do whenever you're trying to figure out, am I going to run a chi-square test or am I going to look for a correlation, is you want to figure out what type of data that you're working with. Because the reality is, while it's not necessarily wrong to look for a correlation when you're working with nominal level data, it's not entirely the most accurate way to be able to meaningfully discern a relationship between that data. Because if you recall our discussion from last time, when you're looking at nominal level data, really all it's telling you is that there is a categorical or a qualitative difference. So correlation is really designed to be used with continuous data. And so it really works better when you're working with either interval or ratio level data. Certainly you can use it sometimes with ordinal level data, but that's not really what it's meant for. It's meant to be used and is best and most exactly used when it's used with either interval or ratio level data. And so let's look at an example of why that would be the case. And so we're going to go to our graphs box, and we're going to go to legacy dialogues. And let's look at a scatter plot. And you don't necessarily need to worry about this operation right now. I'll review how to do it in a moment whenever we're working with real data. This is just an example. And so we're going to look at a simple scatter plot. And let's look at a nominal data. So that would be race. And let's use that as our x-axis. And then let's use thanks for joining a cultural club, which would be ordinal level data. So normally we'd want to have a title, but this is just an example, so I'm not going to worry about that for now. And normally we'd want to paste it so we have syntax that we can use later. But once again, this is just an example to show you why we wouldn't want to do a correlation. And so if we look at the way that this bivariate plot's going to come out, and it's bivariate because bi working with two variables, and variate meaning variable. And so if you look at it, if you remember the video from the correlation, there would look like there's no relationship between these two variables. It looks like there's zero correlation here. And the reason why is because this is just nominal level data and this is just ordinal level data. So you can see these darker circles here means there's more data points in that. But because the way this variables are, and the fact that they're essentially a series of yes and no's, correlation doesn't really quite work well here because these points are not free to vary anywhere within the data set. They're pretty much locked in. And so we don't know what 1 means, but let's assume 1 means Asian Pacific Islander, students who identify as API. We can see that students may be likely or very unlikely, very likely, throughout that data set, but they can't vary anywhere in between there. And so because of that, if you look at this entire plot as an example, it would look like there's no relationship between racial identity and whether or not a student would join a cultural club once they're on campus. But that's probably not the case. That seems pretty circumspect to me. And so let's go back and let's look at our data again. And so let's go down to the bottom here. We have the window view. And let's click on our data set. And if you don't have that in your bottom toolbar, you can also go up to window in your top toolbar and you can select data set there as well. And so let's first look at our descriptive statistics. And so anytime you're working with statistics, you want to look at the descriptive statistics first because you want to get an idea of what may or may not be there. And so let's go into descriptive statistics, frequencies, and let's look at those same two variables again. Race recoded, and thanks for joining Culture Club. And let's go to statistics and see if we want to include anything else. And so each one of these, race recoded is nominal, and join a cultural club is going to be ordinal level data. And so because of that, these measures of central tendency, if you remember our conversation from last time, they're not entirely meaningful. And so we are not really going to worry about including these because they're not going to tell us that much. And the same is true for these measures of dispersion. So we can just click continue because we don't want to include any of these statistics. Then we're going to click paste because we do want to save this syntax in case we want to run this operation later. We highlight the entire operation and click our green play arrow. And that's going to bring up our frequency tables. And so you can see that if you look at the percent, the valid percent, which once again would exclude any missing data. 13% of our students identify as APA, 7.6% identifies African American or Black, 67.5% is white, 4.7% is Latino or Latina, and 7.2% is other. And perhaps what's more telling, if we go down here to thinks we'll join a cultural diversity organization in college, is it would look like the great majority of our students think that they're not going to join a club, right? Because 17% say they're very unlikely and 44.8% say they're unlikely, while only 27.8% are likely and 10.4% are very likely. And so, it would be easy to say, if we were just looking at it in a vacuum, as thinks we'll join a cultural diversity organization without considering race as a factor at all, to say, well, it looks like most of our students wouldn't be interested in joining a cultural club. But we might be interested to know, okay, is there a relationship? Is there a relationship between race and thinking that you will join a cultural diversity club? And so the first step in that is we want to look at crosstabs. And so crosstabs is a way to be able to look at whether or not there might be a relationship between these two variables. And so under Analyze, Descriptive Statistics, you'll see the crosstabs. So select that. And then let's put thinks we'll join a cultural club as our row. And let's use race as our column. And let's see if there's any statistics we'd like to include. And so for right now, I'm not going to worry about any of this. We'll come back and look at these in a moment. So we're going to click Continue. Let's look at cells. Okay, let's include expected for now, and let's just take a look at that, and then we'll come back and add our percentages in a moment. So what's actually going to happen, and I'm just going to click OK because I just want to show you something here. So what chi-squared does is it actually uses these counts. So this is what's observed. This is how many students who identify as Asian Pacific Islanders / Asian say they are very unlikely to join a cultural club. And this is how many of those same APA students who say that they would be very likely to join are 7, right? So these are what's actually observed. And what it's doing is you have these expected counts. So 6.1, 16.1, 10, 3.7, 36. And these are based upon taking this total here that you see across the bottom. So 36, 19, 13, 183, and 19, and then breaking that down based upon the rows. And so if we add in the percent, it'll better illustrate that for you. So go back to crosstabs, and in the cells, now we're going to click row, column, total for percentages. We're going to click paste because we do want to save this. And we're going to go to our syntax window, and we're going to highlight that operation, click play. And so now you'll get a better illustration of sort of how that's breaking out. And so you can see that each one of these expected counts here, so 6.1, 3.2, 2.2, 31.2, 3.2, that is based upon how these totals are broken out, right? And so what it's saying is 67.8% of this total of 46 should be represented within this count here. And if we were to do the math on that, which we can, so let's just use this one over here. So we'll say 6.1. So this total is 46 for APA. So if we say 46 times percent of total should be 13.3. Oops. be helpful if I did the right percent, times 0.133, and you can see that is 6.1. So that's where these expected counts are coming from, and that is actually the total that they use in the chi-square test. So they're saying that, if everything was just generic and that, race had no bearing on what is to be expected to see, then these total columns should match across the board regardless of race. There should be no difference, and so you would expect to see 6.1 APA, 3.2 African American Black, 2.2 Latino Latina, 31.2. I'd say they're very unlikely, and that's what you would expect to see if there is no relationship between racial identity and whether or not a student thinks they'll join a cultural club. Now, the way to test for that, so this is crosstabs, right? So this is interesting to see. So if we just look at this and we removed expected account, you could see there's already some interesting differences here. So see, percent thinks they will join a cultural diversity organization. 73.9% of students who identify as white say they're very unlikely to join. And tellingly, those who are very likely, you could see that 25% of those who are APA are very likely, 28.6% for African American or Black. And if you look at white, it's 32.1. It's a much lower percentage there for them. So let's see if that's actually statistically significant, though. So we think that race might be a factor, right? That's where we stand right now, is we think that racial identity is a factor in whether or not you'll join a club. But we don't know yet. We can't say with any level of certainty. And so what you can do is you can actually run a chi-square test, and a chi-square test will help you discern, well, is it statistically significant? Is there any level of certainty that that is in fact a factor? And so all you have to do to be able to run that test, and I'm sorry, I should explain that, is go to Analyze, Descriptive Statistics, Crosstabs, and then we're going to click Statistics. And we want to run chi-square. Now we could run a correlation in here too, but as we discussed earlier, it's not very meaningful because we're working with nominal level data. And so let's look at chi-square. Click Continue. So once again, that was under Statistics, and then that's where you can click chi-square, okay? And we're going to click Paste because we want to save that operation. We're going to go to Window, and we're going to go to Syntax. And let's highlight that operation and click Play. And what it's going to do is it's going to give us that same exact table again, which isn't any different than the table we just looked at previously. But what it will give us as well is this chi-square test here. And so if you remember from the video, if you were to calculate this out, you could take this value of 54.077 and use the degrees of freedom. And the degrees of freedom are based upon the number of rows with the number of columns. Right, so if we counted all that up, it would equal 12. And so this degrees of freedom, to be able to calculate and look at a chart to see is this statistically significant. But we don't have to do that because SPSS does the work for us. And so we can see here that it is statistically significant at the alpha level of 0.05. And even beyond that, it's statistically significant at the alpha level of 0.001. Because you can see that it is so small that it isn't even represented here. So sometimes if you double click on it, it will show you, but it's so you could see right here that I can't even do the math. But if you were to take that 2.6473, you would have to move your decimal point 7 places to the left. And that is how small that significance level is. And what that means is that is the likelihood that this relationship exists by error. And so what we know from this chi-square test is we know that there is a significant relationship between race and whether or not you think you'll join a cultural diversity organization. And really what it tells us is that there's a significant difference between what is observed and what is expected. And we know there is a difference. It is a statistically significant difference. But what we don't know is we don't know where that difference lies. We don't know if that's primarily in white students who would be expected to say they're going to join a cultural diversity organization at a higher level than they do, or an African American student. We simply don't know where that exists. But we do know crucially that there is a difference. And that is what the chi-square test will do for us. And so the last piece of this element is, we might want to represent this visually. And the easiest and best way to represent it visually is the same way that we did previously, which is to use a bar graph. And so if we go to Graphs, Legacy Dialogues, Bar, and we pick Clustered, because we want to do the same type of thing that we did with its crosstabs and visually show how likely a student is to think or to expect to join a cultural club based upon race. So we're going to define, and we want to use percent of cases because remember, once again, number isn't going to be quite as descriptive as percent's going to be. And for the category axis, we want to use thanks for joining a cultural club, and we would define those by race. And we always want to include a title, so click Titles. So this is going to be student expectations of joining cultural diversity club by racial identity. And click Continue, and then click Paste. So we have the syntax. We'll go to our syntax window. We'll highlight our operation, and we'll click the green play arrow. And that will generate a nice bar graph for us here. And so you can see that visual representation of what we looked at in our crosstabs table here. And you could see that for white students, their overwhelmingly majority is unlikely to join a club, right? However, if you look at Latino students, the overwhelming majority are likely to join a club, as represented by the beige graph. Now, we also want to show you how to be able to perform a graph in Excel. And so the first step, if you wanted to actually look at your data in Excel, is to generate this crosstabs table, but in a super condensed version, because we don't want to have to mess with all these separate data points. And so let's go to Analyze, and we'll go to Descriptive Statistics, Crosstabs, and let's really slim down what we're including. So the rows and the column are going to be the same, but in Statistics, let's get rid of chi-square because we don't need it for this. And in the cells, let's get rid of our counts of expected. We don't need that. Let's get rid of our percentages. We don't need that. We don't need any of those things in here. We just need our observed actual data because we just want to provide a visual representation of it in Excel. So click Continue. We'll click Paste. We'll then open up our syntax window. We will highlight that operation and click the green play area to run it. Okay, and that's going to bring up a super slimmed down crosstabs table here for us. Now, just click on that to highlight it, and I'm going to copy it. I'm using a Mac, so it's going to be your Command C on a Mac. It would be Control C on a PC. And then I'm going to open Excel. It doesn't matter, just open a blank workbook. Then I'm going to highlight that top corner, the A1 cell. And on a Mac, it's going to be Command V. On a PC, it'd be Control V, but I'm just going to paste. So I'm going to paste in that table. And now what I'm going to do is I'm going to highlight that table. And I'm going to insert a bar graph. Okay, and you can actually use this recommended charts here too, and it more likely will tell you what you should run. So it's saying it doesn't know what I should run, which is fine. I know what we should run. So we're going to not that. So it should, if we eliminate some of these, help us out here. So if you get rid of the top part here, now it's going to show us what it recommends. So we want to run a clustered column, which is no different than a clustered bar graph, which is what we were running in SPSS. And so if you click that recommended charts, now that I'm not highlighting this information here, it will tell us that. So if you just highlight the actual information that's going to be used in the bar graph and click recommended charts. It'll show you that for us. But if you want, you can also click on this and go to more column charts, and it'll show you the same thing here. So the choice is how we want to represent it. And let's say we don't want to include the total. The easiest way to eliminate the total is you simply don't highlight the total. And we could have it either go by the racial identity, or we could have it go by whether or not what they're likely to select. So I think it's easier to use the to group them by race. And so let's use this one. And so all you do is you double click on it, which will open it. And then to change the chart title, you just click on chart title, which will open the dialog box. And we want to say this is thinks will join cultural diversity organization by race. I have no idea if I might have spelled the word wrong there. And you can make it bigger by holding in the right corner, simply dragging it out, which will make it bigger. And you can see this is giving you expected counts. If you wanted this to be changed, then you would have to change these into percentage. But that's a basic of how you can generate that chart in Excel. So the second thing that we want to look at is we want to consider what you would do is if you wanted to look at a relationship between interval or ratio level data. And so in the same way that a chi-square is appropriate when you're looking at nominal or ordinal level data, a correlation is the best way to look at how two variables vary together. And that's really what a correlation is about. All it does is explain the relationship between two variables, and it explains that relationship by explaining how much those two variables vary together. And so how much do they move with one another? And in what direction do they move? And so let's look at the variables. So let's go back to our data window. So window, data set. Let's look at the variables and the first step is we want to look at frequencies, obviously. So we can look at our descriptive statistics. So let's look at the variables of SAT, which if you remember, SAT is interval level data, and high school GPA, which is ratio level data. And the difference being that there's a true 0 in GPA and there's not a true 0 in SAT score. So let's look at statistics. And for this, they are interval and ratio level data. So measures of central tendency are meaningful for them. So let's include them, as are these dispersions. So let's include standard deviation and range. Continue. Paste, so we can save the syntax. Window, we'll go to our syntax window. We'll highlight that operation, and we'll click the run operation, green arrow. And so first it's going to give us this frequency table with all our valid percents. And for this purpose, because of the type of data we're dealing with, this isn't entirely meaningful, right? Same with the high school GPA, not entirely meaningful. However, the mean, the median, the mode, these are really what's interesting and what's going to tell us where we sit. And so the mean for our data is a 1258 in the SAT score and a 3.79 in the high school GPA. And what's interesting, what we may want to know is, well, how do these two things vary together? What is the relationship between SAT score and high school GPA? And I would surmise that there's actually quite a bit of a relationship, but we don't know. We don't know yet. We can say that there might be, but we simply don't know that yet because these are two separate variables that we're looking at. We want to look at them together. And so we could say, well, you know what, let's try to use crosstabs for them. So descriptive statistics, crosstabs, and let's use SAT score. And let's use GPA. And let's just click OK. Let's just take a look at that. Whoa, that is a lot to look at. That is tough to understand what's going on there. And the reason why that is because you have basically ad infinitum categories, because these are continuous level data. And when you have continuous level data, chi-square isn't entirely useful because it doesn't work when you have less than 5 observations in any one category. And so you can see there's a lot of zeros in here, and that's because there's so many different variations. So because of that, a correlation is a far more appropriate test to run, because correlations are well used for continuous level data. So we're going to go to Analyze, we're going to go to Correlate, and we're going to do a bivariate correlation, which all that means once again is that you're working with 2 variables by 2. So those 2 variables that we want to work with are SAT score and GPA, and it doesn't matter what order you put them in. All it will do is change how they're laid on the table. It won't change the actual test statistics. Let's look at options, and we don't need to include any of these, so we don't need to worry about that. And we want to run the Pearson correlation coefficient, which is the default setting, so we're just going to leave all of these alone. Click Paste, and then we're going to open up our syntax window. We're going to highlight that operation, click the green play arrow, and that's going to give us our correlation. So you can see that we have a correlation of 0.305, and we have a significance of 0.000. And so what that means is that this correlation of 0.305 is significant at the alpha level of 0.001, which means it's statistically significant. You know, it's easily statistically significant. The likelihood that we have found this outcome by complete chance is very, very, very slim. That's what that 0.001 means. And so if you remember from our previous video, though, this would say this is a relatively weak correlation, which that's frankly kind of debatable. It depends upon what area you're looking at. A 0.305 in the social sciences is might actually be considered more of a mid-sized correlation, but it's also positive. And what that means is as GPA goes up, SAT score will go up, and vice versa. So they move in the same area. And we might want to look at this visually as well. A bar graph, once again, though, is not going to be helpful, and I won't even show you because it would be such a mess. But a bar graph is not going to be helpful because it's going to have so many different options on it. What is helpful, though, is if we look at that scatter plot that we looked at previously. And so we want to do a simple scatter. We're going to define it. And let's pick our 2 variables. So let's use SAT score as our x-axis. I'm sorry, let's use GPA as our x-axis. And let's use SAT score as our y-axis. And generally, you know, you could set this up either way that you would like, but generally whatever your x-axis is what would precede or might predict, and that we're not going to do that today, but would predict or precede your y-axis. Always need a title, so click Titles, and we're going to say this is relationship, because that's what we're looking at with correlations, is what are the relationships. A relationship between high school GPA and SAT score. Click Continue, click Paste, open your syntax window, highlight that operation, click your green Run Operation arrow, and it's going to bring up our nice scatter plot here. And so what we're looking at is what would be the trend in this data. And it can be kind of difficult to tell because it kind of looks like a blob. But if you look at it, it looks like generally it's positive, which would align with our correlation. And it looks like it's you know, a relatively strong correlation, meaning there's a tight cluster here. So you might have a positive correlation, but you might see a lot of data points sort of spread out, like here, 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 everywhere, right? And the more loose the grouping is throughout here, you know, the less strength there is in the correlation. The tighter the grouping, the stronger the correlation. And so if you look at this here, this looks like this is a relatively strong correlation. And the other thing that you're looking for is, you know, what is the peak of that correlation? So if it's a really sharp line like that, the stronger the correlation. The flatter it is, the weaker the correlation, to the point of if it's completely flat, there's no correlation. So if we wanted to take a look at that, we can double click on it, which will open our chart editor box, and we can add a fit line to it, which fit lines are really used for something for regression analysis, which we're not going to worry about. But what they're useful for in correlation is they can sort of give you a visual representation of what is the relationship, what is the strength of that relationship. So let's add that fit line. If you can see, it's in here on my toolbar in the bottom half, add fit line at total, and just click it. And you can just close this property window and close your chart editor box. And it'll leave your fit line in there. And it'll actually show you an R-square statistic, which we're not going to discuss today. That's the coefficient of determination, so we're not going to worry about that. But what it will show you too is it'll give you this fit line. So this is that same type of line that I traced for you earlier, showing you what is the direction of the relationship between the two variables and what is that sort of strength between the relationship. And all that is a visual representation of what does the relationship look like, but it doesn't give you any information that this correlation analysis that you ran previously already gave you. So that is a quick overview, relatively speaking, of how to perform correlations and chi-square analysis in SPSS, and we will obviously work on this in class as well. If you have any questions, you should please feel free to post those in the comments box, and Heather and I will answer those as we see them. All right, thank you very much.